One thing that I didn't do in the last example but meant to was show you the demonstration that a plane is determined by a point and a normal vector. So here is our plane with the red normal vector, and then ABC, those are the components of the normal vector. Here's the current equation of our plane. So notice here if I change the A, so I'm changing that red vector, you see the plane tilts in a different direction. So the normal vector controls the tilt of that plane. Here's changing the B. You can see how the equation changes. And then here's changing the C. So every time you change that normal vector, you're changing the tilt of that plane. So let's look at another example here. We want to find the equation of the plane through the points P, Q, and R. So let's draw a picture. So we've got this plane here, and it goes through points P, Q, and R. So let's say P is here, and Q here, and R here. So you only need 3 points to determine a plane. How are we going to get, we've got a point, how are we going to get a normal vector out of these three points that we're given? Well, remember a normal vector, remember that a cross product gives a vector perpendicular to two given vectors. So what we could do is we could find the vector PR by subtracting coordinates and the vector PQ, and then our normal vector, we could take the cross product here of those two. So this will be perpendicular there and perpendicular there. So our normal vector here is going to be PR cross PQ. So let's go ahead and find PR. So let's see, P to R, we're going to do end minus start. So 1 minus 1, 0. 0 minus 2, negative 2, and negative 1 minus 3, negative 4. And then we need PQ. So n minus start again. So negative 2 minus 1, negative 3, 3 minus 2, 1, and then 1 minus 3, negative 2. And then PR cross PQ. Let's swap that out. Let's do PQ cross PR. Kind of do them alphabetical. So it's just going to be the difference of a minus sign. But let's go ahead and do it that way. So then our normal vector is going to be a determinant. We've got ijk in the first row, and then PQ, negative 3, 1, negative 2 in that second row, and then PR, 0, negative 2, negative 4 in the third row. So let's see here. So take out row and column of I. We've got 1, negative 2, negative 2, 4. Oh, well, let's set this up first. So this is a 2 by 2 I minus a 2 by 2 j, and then plus a 2 by 2 times k. So we took out row and column for I. We had this matrix left. So that's 1, negative 2, negative 2, negative 4. Take out row and column for j, 3, negative 3, negative 2, 0, negative 4. Take row and column for k out, negative 3, 1, 0, negative 2. So now subtract your cross products. So this will be what? Negative 4 minus negative 4, so 0 and the I component. 12 here minus 0, and then a negative out in front, negative 12 in the y. 6 minus 0, 6 in the j. So there's our normal vector. Oh, wait a minute. Negative 4 minus positive 4, that'll actually be negative 8. Sorry about that. So that's our normal vector. That's ABC. And then we can use any one of the original points to be our x0, y0, z0. Why don't we just use P? So then we just kind of plug into our scalar equation of the plane. So A, -8, and then B, -12, and then C is 6, and then it'll be x minus 1, y minus 2, z minus 3. And then 0 on the right-hand side, and we've got it. So there's our scalar equation. So, okay, so a couple examples for me. Try the next Cadley question and see how you do there.